The second method, depth first search traversal. So in this method also the same procedure. First one, initially all the vertices of the graph are unvisited vertices. Now initially select a starting vertex indicated as U, place it into a data structure called stack. Remember this point, here we use stack data structure and make it as visited vertex. Delete element from the stack, put it in the traversing output and explore all of its children nodes. Listen, when the vertex is deleted from the stack, now it enters into traversing output. Simultaneous thing, it explore all of its children nodes. In this case, children nodes are placed in the stack in reverse order is another important point. Children nodes are placed in the stack in reverse order and make them as visited vertices. Now the above procedure is repeated until all the vertices are visited and entered in the traversing output. So in depth first search traversal, the key points are vertices are placed in stack data structure. Its children nodes are placed in stack data structure in reverse order. So when we observe these points, we can simply implement depth first search traversal. Now take this example. Again the same example as we are implemented in breadth first search traversal. The same graph. So first we design adjacency list representation. Again the same format. Since you are familiar with adjacency list representation, so first design adjacency list representation for the given graph. Now we design a table format that consists 4 columns like current vertex, stack, traversing output, status of visited vertices. From the graph, the existing vertices are 0, 1, 2, 3, 4, 5, 6. Initially, all the vertices are unvisited vertices, hence place the status values as 0, 0, 0, 0, 0, 0, 0. Now, the procedure starts from the starting vertex 0. Hence, first 0 enters into the stack data structure. Now, change the status of 0 as visited vertex. Now, delete 0 from the stack. Now, the current vertex becomes 0. Simultaneous thing, 0 enters into traversing output. Now, 0 is ready to explore all of its children nodes. Now, the children nodes are 1 and 5. Now, observe the status of 1 and 5. Here, 1 unvisited vertex, 5 unvisited vertex. Hence, these two vertices are placed into the stack data structure in reverse order. This is an important point. Those are placed in reverse order. Now, change the status of 1 and 5 as visited. Now, based on the stack principle, the last inserted element becomes the first deleted element. Okay? The last inserted element is the first outcoming element. Hence, first delete 1 from the stack. Now, 1 becomes the current vertex and it enters into traversing output. Now, for 1, the children nodes are 0 to 6. Now, 0 already visited vertex, 2 unvisited, 6 unvisited. Hence, make these two vertices as visited format. Now, these are visited vertices. Now, 2 and 6 are enters into the stack data structure in reverse order. Hence, these two vertices becomes 6 and 2. Now, the status of the stack is 5, 6, 2. Now, the last inserted element is 2. Hence, it deletes from the stack data structure. Now, 2 becomes the current vertex and 2 enters into traversing output. Now, the adjacent vertices of 2 are 1 and 3. Now, 1 visited vertex, 3 unvisited vertex. Hence, make it as visited format. Now, the visited vertices are now this one. Now simultaneous thing, 3 enters into stack data structure. Then delete 3 from the stack data structure. Now 3 becomes current vertex and enters into traversing output. Now the vertices of 3 are, adjacent vertices of 3 are 2, 4, 6. Now 2 visited, 4 unvisited, hence make it as visited, 6 visited. Okay. So now these are all visited vertices. Now 4 enters into the stack data structure. Now delete 4 from stack data structure. 4 is the current vertex and enters into traversing output. Now the adjacent vertices of 4 are 3, 5, 6. Now 3 visited, 5 visited, 6 visited. Okay. So all are visited vertices. Now delete 6 from the stack data structure. Now 6 is the current vertex and enters into traversing output. Now the adjacent vertices of 6 are 1, 3, 4. 1 visited, 3 visited, 4 visited. So all are visited vertices. Now delete 5 from the stack data structure. Now 5 is the current vertex. 5 enters into traversing output. The adjacent vertices of 5 are 0 and 4. 0 visited, 4 visited. So all are visited vertices. Finally, stack reaches to empty situation. Okay. Now, when stack reaches to empty situation, now terminate from the process. Now, the traversing output becomes 0, 1, 2, 3, 4, 6 and 5. That means finally the depth first sets traversal output. That means the vertices of the graph are visited in this order 0, 1, 2, 3, 4, 6 and 5. Okay. Now this one depth first sets traversal. Now finally observe these two methods. So in breadth first sets traversal, it uses Q data structure, whereas in depth first sets traversal, it uses stack data structure. In breadth first sets traversal, children nodes of the current vertex is placed as in the same order, whereas in case of depth first sets traversal, the children nodes of the current vertex are placed in reverse order. It's an important point. Okay. So in this way, these two methods are implemented to traverse the vertices of the given graph. Thank you. I hope all of you understood these concepts. So in next session, we will meet with another concept. Thank you. Thank you, one and all.